Let's sketch the ellipse. It's tangent to the x-axis, and we'll label the foci A and B. We'll let P be this tangent point. Now I'll find the reflection of this point B across the x-axis, and we'll call this point C. I'll draw a segment AC, and we'll call this point where AC intersects the x-axis, we'll call that Q. And we'll note that the distance from Q to B is the same as the distance from Q to C, and PB equals PC. We have the distance from A to C is AQ plus QC. We'll substitute QB for QC. We're interested in the length of the major axis. Since P is on the ellipse, we have that the distance from P to each of the foci sum to the length of this major axis, which I'm calling K. If Q is not the same as point P, but it's some other point on this tangent line, then Q has to be in the region outside of the ellipse, and the distances from Q to A and the other focus will be greater than K. We note that if we have PA plus PC, we can substitute PB. This again is K, and we have the sum of these two distances is greater than K. So we have PA plus PC is less than the sum of QA plus QB. The sum of these two distances is AC, but if we apply triangle inequality to triangle PAC, we must have the sum of any two sides of this triangle be greater than the third side. So we have a contradiction here. We can rectify this if P and Q are actually the same point. So we'll redraw our ellipse tangent to the x-axis. This is one focus A. It's going to pass through the tangent point P, which is now the same as Q. And so our second focus is going to be directly above C. We're trying to find the length of our major axis. That's going to be the distance from any point on the ellipse to the two foci. As before, we'll replace PB with PC. And since these 3 points are collinear, this is the distance from A to C. So we'll use the distance formula, and our answer is 85. If you'd like me to solve any other math contest problems, please leave them in the comments.